So in this video we are going to attempt some of the structured question of periodic trends and related to AP chemistry. So first of all, why atomic radius decrease across a period? So what happens? Atomic radius decrease across period because of increase in nuclear charge. Atomic radius decrease across period because of increase in nuclear charge. Increase in nuclear charge. In the next question they say predict which element has the smaller atomic radius, magnesium or aluminium. So magnesium is having 12 and aluminium is having 13 proton numbers. So we know atomic radius is inversely proportional to nuclear charge. So in fact aluminium has smaller atomic radius because of increase in nuclear charge. Sodium and chlorine are in the same group. Compare their atomic radii and explain the difference. So sodium is having 11 and chlorine is having 17 as proton number. So sodium 11 has greater atomic radius than chlorine. Why? Because chlorine has greater nuclear charge and as they both belong from the same period, so they have same shielding. That means shielding electron remain constant throughout the period. Define ionic radius. So what we mean by ionic radius, that is the distance from the nucleus to the valence electrons. Then they say predict whether magnesium ion or sodium ion will have smaller ionic radius. So magnesium ion is having proton number of 12 and sodium is having proton number of 11, and they both have same electrons because Mg plus 2 is having 10 electrons and sodium plus is also having 10 electrons. So which is having the smaller ionic radius? So definitely Mg plus 2 has smaller ionic radius because of greater nuclear charge pulling electrons closer. So in the next question they say explain how the ionic radius changes when sulfur forms an anion. So when we are trying to add electron to sulfur, sulfur has 6 electrons in its outermost shell. So when we are trying to add two electrons to sulfur, then due to repulsion between there will be a repulsion between these valence electron and the upcoming electron. And the upcoming electron, what will happen? There will be the larger ionic radius. There will be larger ionic radius. So how can we write it? Adding electrons to sulfur increases electron repulsion, resulting in larger ionic radius. So in the next question they say define first ionization energy. So what we mean by first ionization energy, that is the energy required to remove 1 mole of electron from 1 mole of gaseous atom. So in the next question they are saying complete the first ionization energy of lithium, which has proton number 3, and sodium, which has proton number 11. So they say like they basically present in group 1, and lithium is Li3 and sodium is Na11. So Na has lower first ionization energy. What is the reason? Then Li, because of greater atomic size and because of increased shielding Explain why first ionization energy of oxygen is slightly lower than that of nitrogen despite the trend. You know, oxygen is O8 and nitrogen is N7. Although because of greater nuclear charge, the ionization of energy of oxygen should be greater, but in fact it is lower. What is going to be the reason? If we see electronic configuration of oxygen, it is going to be 1s2, 2s2, then we have 2p4. And if we see nitrogen, it is going to be 1s2, 2s2, 2p3. So if we see 2p4 orbital in oxygen, it is going to be like this. And one electron will be here like this. So if you can see, we have to remove the electron from oxygen from 2p orbital, and this 2p orbital have 2 electron in the same orbital, and because of repulsion there will be the repulsion. Because of the repulsion between the electron, it is going to have low ionization energy. So if we see a nitrogen 2p orbital, it is unpaired and the electrons are like this. So we need to provide it more energy because there is no repulsion. So how can we write it that oxygen has paired electrons paired electrons in the 2p orbital, in the 2p orbital, causing electron repulsion, electron repulsion. And because of that, what will happen? And lowering ionization energy. Then in the next question, they say that the atomic radii of Na, Mg, and Al decrease across period 3. Explain this trend using nuclear charge and electron shielding. So what happens across the period as the Na is having 11 proton, 12 proton, Al is 13. As nuclear charge increases across the period, then atomic radius decrease because of greater attraction of nucleus to valence electron. So in the next question, they say chlorine and iodine are both in group 17 elements. So we know it is group 7 is fluorine.
Are you marking?
And then bromine and
Yes.
iodine. So in the next question, they say that chlorine and iodine are both group 17 element. Predict which the two has greater first ionization energy. So we know that chlorine is present above and iodine is present below. So chlorine has greater ionization energy. As we know, ionization energy decreases downwards. So it has greater ionization energy. And what is the reason for that? As it has few electron shells. So chlorine has greater ionization energy as it has fewer electron shells. One thing. Second is going to be iodine valence electron are further from the nucleus, and more shielded. So there's an anomalous behavior they are talking about. They say the electron affinity of chlorine is more negative than that of fluorine, even though fluorine is more electronegative. Why is that? So first of all, you must know that fluorine has very small atomic radius, and because of small atomic radius, what happens when electron has been added into it? There is more electron repulsion. Okay, so what we can write here, that fluorine has more electron repulsion due to small atomic size, and chlorine has slightly larger atomic radius, slightly larger atomic radius. Why? Why it has slightly larger atomic radius? So the added electron experience less repulsion and making the process more exothermic more exothermic. For the next question, a student proposes the following isoelectronic series O minus 2, F minus, Na positive and Mg plus 2. O minus 2 is having the atomic number of 8 and fluorine is having the atomic number of 9, the proton number, and sodium is having 11, magnesium is having 12, and they all have same number of electrons in their outermost shell. So what happens now that maybe they don't have the same number of electrons in their outermost shell, but their number of protons are different. So we know greater the nuclear charge, the smaller will be atomic radius. So the one which is going to have this greater nuclear charge, that is Mg plus 2, and it is going to have you can say the smallest atomic radius. Then we have Na positive, then we have F minus, and oxygen, which is having the lowest atomic number, which is the lowest nuclear charge, is going to have the greatest atomic radius. Okay, and the answer to this one, we can also write that the nuclear charge increase across the period, and resulting in stronger attraction and smaller atomic radius. Then for the next question, they say magnesium and nitrogen form the ionic compound Mg3N2, and now they say that compare the relative ionic radii of magnesium plus 2 and N minus 3 ions. So magnesium is having the atomic number of 12 and nitrogen is having the atomic number of 7. Now what happens, like they both have the same number of electrons, they are isoelectronic, so they have same electrons, and if they have same electrons, then the one which is having the lower nuclear charge is going to have the greatest atomic radius. So we can write here that N minus 3 has the larger ionic radius than Mg plus 2. And what is the reason for that? That Mg plus 2 has greater nuclear charge as compared to n minus 3. In the next question, they say predict whether sodium or phosphorus is more likely to form a basic oxide. So remember, metal they always form basic oxide, while non-metals they form acidic oxide. So which is metal? Metal is sodium and non-metal is phosphorus. So we can say that sodium forms basic oxide as it is a metal, as it is a metal. Then we have to explain the relationship between ionization energy and Coulomb's law. So ionization energy increases with stronger Coulombic attraction. Due to higher nuclear charge and smaller radius. Rank the element beryllium boron Li in order of increasing first ionization energy. As we know, ionization energy increase with the nuclear charge. So boron is 5, beryllium is going to be 4, and lithium is going to be 3. So the one which is going to have a greater nuclear charge is lithium is 3, beryllium is 4. Yes, so the one which is going to have greater nuclear charge is going to be, the nuclear charge increases in the form of boron, then beryllium, then lithium. And why we are going to see this anomalous behavior? Because lithium has the electronic configuration of 1s2, 2s1, then beryllium is having the electronic configuration of 1s2, 2s2, and boron is having 1s2, 2s2, 2p1. Then we are going to see that ionization energy generally increases across a period due to increase in nuclear charge. However, boron has lower first ionization energy. However, so we can write here that ionization energy generally increase across period. But what happens here, due to increase in nuclear charge, but what happens here, however, boron has lower first ionization energy, and the reason is going to be then beryllium, due to outer electron being in a higher energy sublevel, which is more shielded. So So you can see it has the greater shielding as compared to beryllium, which has only 1s2.